Crops for biodiesel contain between 4 and 62% extractable vegetable oil by weight. Oil is extracted either physically by a mechanical press or chemically with organic solvents such as hexane. The production of biodiesel involves the reaction of the extracted vegetable oil or animal fat with methanol or ethanol in the presence of a strong base, and then separation of the resulting biodiesel from the unreacted alcohol and base and from the glycerol that forms. The efficiency of extraction conversion is 89%, but the economic viability of the process depends on the value of the 38 to 97% of biomass that remains after oil extraction. Fundamental questions remain about the extent to which biofuels could supplant fossil fuels. Different budget analyses for biofuels reached widely discrepant conclusions. Estimates of greenhouse gas emissions per unit of energy obtained from biofuels vary tenfold. In addition, some analyses indicate that the energy in biofuels is nearly double that of the fossil fuels expended to grow the biomass and process it, whereas a few others find that the energy in biofuels does not even match that of the fossil fuels expended. Several assumptions are responsible for these discrepancies. Some analyses assume that sustainable production of biomass will require substantial fertilization and irrigation with prolonged fallow periods, whereas others assume that cellulosic crops will require minimal additions of fertilizer and water. Analyses also differ in their assumptions on the proportion of energy for processing that might derive from the biomass itself. Some argue that as much biomass as possible should remain in the field to maintain soil fertility. Others argue that leaving biomass in the field just lets a valuable resource rot. As the biofuel industry matures, many of these discrepancies will resolve. How realistic is the goal of replacing 30% of oil use in the United States with alternative fuels by 2030? One can calculate that to replace 30% of the United States oil consumption with bioethanol from maize grain would require a total of 800 million hectares per year. For perspective, the total land area of the United States, including Alaska and Hawaii, is 900 million hectares, and currently 38 million hectares are in maize production. Even optimistic estimates for cellulosic ethanol yields indicates that the biomass required to meet a 30 by 30 goal would cover 120 million hectares, an area larger than the states of Texas and California combined. In summary, number 1, procedures for direct burning of biomass, fermentation of sugars to ethanol, and cellulose purification are straightforward. Number 2, conversion of cellulose into ethanol is still inefficient. Number 3, the goal to replace 30% of all oil use in the United States with alternative fuels by the year 2030 seems overly optimistic.